p.69, problem number 9. If one card is drawn from a standard deck of 52 cards, find the probability of getting these results. Well, let's take this one at a time, but we need to realize that for these probability problems, we're always picking some number of cards out of 52 total cards. So, like for example, this first one, probability of getting an ace, our answer is going to be something out of 52. So we need to think to ourselves, how many aces are in the deck of cards? There are 4 aces, one of diamonds, hearts, clubs, and spades out of 52 total cards. Now this answer is 100% correct. We can reduce our fraction. This is unnecessary. In fact, sometimes it's better to keep the original fraction because then we can see exactly how many aces, how many total cards. Just realize this is the exact same answer. And in fact, sometimes people will write these as decimal answers, which is fine as well, which would again be 100% correct. Okay, let's take a look at the next one. Probability of getting a diamond. I'm going to bring that over here and think how many diamonds are in the deck. Well, we can go through and count them all. If you do ace through 10 and then jack, queen, king, there are 13 diamonds out of those 52 cards. Which if you reduce that fraction, you get 1 out of 4. Now in this case, 1 out of 4 makes perfect sense because there are 4 suits in the deck, diamonds, hearts, clubs, and spades. One of those suits is diamonds out of the 4 suits. Okay, let's take a look at the next one. Ace of diamonds. Well, there's only one ace of diamonds in the entire deck out of those 52 cards. Okay, part D, a 4 or a 6. Now, a lot of times people get thrown off by this word or, and they think that there's some complex mathematics they have to do. Not necessarily. We need to think to ourselves, how many 4s are in the deck? There's 4 of them. How many 6s are in the deck? There's 4 of them as well. So there's 8 total cards that would work here out of those 52 cards. And again, if you choose to reduce that, I believe you will get 2 out of 13. Okay, this next one. This is one that a lot of times people have trouble with, a 4 or a club. So people think, okay, I know there's 4 4s. I know there are 13 clubs. So shouldn't the answer be 17 out of 52? And that actually is an incorrect answer. Well, let me get the over 52. I know that part is right. Here's why 17 is incorrect, because we've got our 4 4s. One of those 4s is the 4 of clubs, so it's already counted here. So really, we don't have 13 more cards, we have 12 more cards. 4 4s, one of those was a club, so then we have 12 other clubs. So there's really 16 total cards that would work here. And again, that fraction could be reduced. Some people like to think of it that way. Other people will say, well, let's take the 4 4s and let's add to it the 13 clubs, and then let's subtract the overlap, the 1 card that is the 4 of clubs. Either way you think of it, you get 16 out of 52. Okay, let's think about this next one, a heart or a club. Well, I know there's 13 hearts in the deck, there's 13 clubs in the deck, so there's 26 total cards that will work out of 52. And if this fraction is reduced, you get an answer of 1/2. Which again, thinking of the situation makes sense because hearts and clubs, that's 2 of the 4 suits, that's half the deck right there. So half makes perfect sense. Okay, next one asks us, what's the probability of getting a red queen? So again, there's 52 cards in the deck. How many red queens are there? Now you could do some different calculations or just count. There are 4 queens total, 2 of them are red. And there's your answer. You can reduce it if you choose. This answer is perfectly okay. Okay, next one, a red card or a 7. Well, I know in my deck of 52 cards, half of them are red, so 26 of those cards are red. I know there's 4 7s, but before I even write down 4, 2 of those 7s are red. 7 of hearts, 7 of diamonds, 2 are black. So 2 of them are already counted in this 26. So I've got 26 red cards. I've got 2 additional cards that will work. So my answer is 28 out of 52. And again, we can reduce that if we choose. I believe that'll reduce to 7 over 13. Okay, last one, a black 10. There are 4 10s in the deck. 2 of them are black, so we get an answer of 2 out of 52. And again, we can reduce that if we choose to 1 over 26.